Hi there, it's Artem. I'm a software engineer at Crown Platform, and today I'm going to show you how to set up a local testnet sandbox to quickly test your Crown core changes, or if you're developing an application using some Crown Platform features like an NFT framework, it's also going to be useful to quickly test your application logic using your own sandbox environment. I'm going to share my screen now. Okay, so I assume that you have basic knowledge of how blockchains work. I also assume that you know a little bit about the Crown platform, about its infrastructure like master nodes and system nodes. I also assume that you have basic scripting skills and programming skills. Okay, so basically to set up a sandbox on your local machine, you will need the Crown core binaries and the scripts folder from the Crown core repository. So first I'm gonna download the latest testnet build from the GitLab server. You can download it from here as well, or you can build it using the source code. I guess I already have the build, just gonna delete it so I don't have a copy of it. Okay, so download. Yes, save it here. And it's done, I guess. Yeah. So I'm just gonna unpack it. Okay. So I'm gonna show you the scripts folder and the actual file that performs all the logic for setting up the testnet environment, local testnet environment. I'm gonna use my IDE for that. So basically, you have the scripts file in the Crown core repository. You can also see this folder right here, okay? And it has the sandbox py file. Basically, all the logic for setting up the local testnet resides here. You don't need to care about this one. It's just a file that tests actual sandbox logic. So I'm gonna show you how it works and the main comments of it. Okay, so basically the py script has 4 main comments: the prepare comments, the start, stop, and simulation comments. It also have a CMD, which means that you will be able to call any API comments of the node that will run on your local machine using the script. So another thing that I need to say is that the simulation happens in a way that every different node is running on your local machine, but they have different port. That's how they can all run locally on your machine at the same time. This is not some kind of script simulation that's going to simulate the running of the Crown core for you. These are real running nodes. So if you're going to set up a lot of nodes, you will need to have a very powerful computer. So besides these comments, we also have arguments for the script. They are mandatory. The first argument is bin directory. It's a path to the binaries of Crown core that you want to use for setting up the local testnet. They all will have to use the same version, like the binaries I just downloaded. or if you're testing your local changes, you can simply compile it locally and put the directory to this argument. Another argument is the directory to the actual sandbox. This is the directory that will contain all the folders for the nodes they're going to run on your local machine. So if you're going to have 5 nodes running on your local machine, it will have the sandbox folder with those 5 blockchains. And the third argument, called file, is a sandbox description file. This file must have a JSON extension. It's a JSON file that contains the actual structure of your sandbox, what kind of nodes your sandbox will have, how many master nodes, what are going to be their names, because that's how you differentiate from them, between them, sorry. So I'm going to show you an example JSON file. And I'm also going to mention that in the scripts folder, there is a template file that has a JSON.in extension. And you can generate your own JSON structure of the sandbox from this one. I already have an actual sandbox file that I'm using for my local testnet. So I'm gonna explain the structure of it using this file. So the first thing you will need to set up is the actual name of your testnet. You can have as many local testnet as you want, and they need to have different names. If you want to start, for example, Crown Wallet using Crown QD file, you can simply provide a devnet argument and the name of the devnet, and that's how the binary will know to which network to connect. Okay, so for example, in my case, the name is platform pre-release. The next object in the JSON file is the actual collection of nodes. In every sandbox, there must be at least 2 mandatory nodes. There is seed node and the miner node. The structure of how these nodes are written here is that you put a name of a node. It doesn't have to be the actual seed. It can be anything you want, right? You can type it like this. And this doesn't have to have a name miner. You can call it generator or like anything else. What it makes the actual seed nodes is the parameter here. So all the nodes have objects associated with them that have specific parameters. For example, for the seed node, you need to set up a property seed to true, and you need to create an array of nodes that will be written in the configuration file of the seed node. Basically, its function is like seed nodes in the real network. It connects all the nodes together so they know how to connect to its peers. So in our case, the property add nodes contains a list of all other nodes in this current network. I'm just gonna return the previous names. Okay, so the miner is the actual proof of work miner. And I'm gonna explain in a minute why do we need a miner to bootstrap a local network. In order for it to be a proof of work miner, it needs to have the generate property to set up to true as well. Okay, so a little bit about the consensus protocol at Crown Platform. I suppose some people will know that for a long period of time, our network was using the proof of work consensus protocol. Around a year ago, the community voted to move on to switch to the proof of stake protocol. And we are using a specific version of it in which every master node or system node can participate in the minting process. So the question might be, if we're setting up a clean blockchain, a clean network, why do we need to use the proof of work at all? There are a couple of reasons for that. The first of it is that the proof of stake uses technology that is called stake pointers. So the stake pointers technology is the mechanism that lets our masternode to prove that they're able to stake in the network and generate blocks. And those stake pointers must be at some height in the existing blockchain, which means basically you need to have some blocks to start generating new blocks. The second reason for that is that in order to set up a masternode, you need to create a collateral transaction, and it must have at least 15 confirmations before masternode becomes active, which also means you need to have some kind of blockchain. And the third reason for that is the actual sandbox was created when we had the proof of stake consensus protocol. And in order to recreate it completely, to generate it using the proof of stake only, can take much more work than just keep using the proof of work plus proof of stake bootstrap mechanism. And I doubt that actually it's possible without some kind of weird bug fixing. Anyway, let's keep moving on. So basically, the fair question would be how and when we are switching to the POS, proof of stake protocol, in our local testnet network. So in the devnet params, in the code, we have 500 blocks to be generated using proof of work. Don't worry, you don't need to have to wait for hours or something, because the first thing what it does, the sandbox, when it starts, it preminds 1 million of your local testnet coins. So you can use it to set up master nodes or send it to other node or do whatever you want. The second is the difficulty is very, very low. So the first couple of thousands blocks will be generated very, very quickly. But you have 500 blocks is enough to set up a couple of master nodes and enter them into the network and get enough stake pointers to start generating proof of stake blocks. Okay, so you can have as many nodes as you want. For example, here I have a Percival node and Lancelot node. They're going to be master nodes. And in order for them to become master nodes, you need to create a parameter in some other node. In our case, it's just going to be wallet. You can also call it however you want. But if you're just recreating the structure of standard network, you have a wallet, you have a bunch of masternodes that are connected to this wallet. You're just going to simply type the masternodes that are connected to this wallet and the names of them. You can have other wallets, other masternodes, but you need to make sure you have a powerful machine to run all those nodes, because they all will, the masternode will generate blocks, and all the full nodes will use a lot of RAM memory. Okay, so for the basic testnet, actually 4 nodes is enough. You can run it with just one master node. And for example, you can also give a function of miner to your seed node. But you need to make sure that that the miner stops trying to mine after 500 blocks. That's why I guess, well, it's not really a good idea to put it here, because after 500 blocks, it's just better to stop it or completely remove it from the JSON file when you restart the network. I'm gonna go into the details when I show you an example. Okay. So what I'm gonna do now is that I'm gonna generate the JSON file and a simplified scripting file from this template. So I'm gonna do everything you're gonna have to do yourself. I'm gonna delete those 3 files that actually are we're using. Wow. I'm not running the testnet right now. What do I? Usually I check for running nodes using this command. Okay, so just gonna create a devnet test JSON file. Okay, just gonna simply copy it here. Just gonna call it sandbox test. Okay, I'm gonna keep the same structure as it is right now, but you can play with it however you want. You can add more nodes or remove them, but as I mentioned before, you're gonna have to have at least a seed node, a miner, one master node, and ideally a wallet. Okay, so now I have the actual JSON file. I'm gonna have to create a structure for the sandbox. So I'm gonna go here. I'm gonna do it in the folder where the binaries, the download binaries reside. I'm gonna create a directory called sandbox. That's where the blockchains will be. And the binaries folder will be just a bin folder. And for the simplicity, I'm just gonna copy the scripts folder from here to the same directory. I can use it from here, but it's just gonna be easier. Okay, so okay, so we have the JSON file and we have the template file. So the template file is just simply a way for us to not type all the parameters each time we want to run a command in the sandbox. Because it has a path to the sandbox, it has a path to our JSON file, and it has a path to the binaries folder. Sorry, and everything else you're gonna put after the name of your scripting file will be put in here. So if you can run a prepare command, start, stop, or anything else, it will put in here. So in our case, the sandbox folder, it just one level up, sandbox, right? Okay. The JSON file is right here in this folder, right? Yeah, I guess so. Devnet test JSON, and the sandbox is going to be in the bin directory, right? Scripts, yes, binary, sandbox. Okay. So now after I run, oops, sorry. Just a moment. Sorry for that. Just gonna open the sandbox file again and explain every comment in the details. What do we have done here? Here, yeah, okay. We're right here. So the prepare command gonna generate the configuration files for each node and put it in a folder with its name. So scripts, prepare, okay. Okay, that was actual template that I changed. Didn't have to do that. I'm gonna do any changes here. Okay, so now I have the actual scripting file that I will be using to run different commands on my local testnet sandbox. You actually can use just a sandbox Python file. It just simplifies life to have a scripting file like this. Something is wrong. It cannot file the devnet JSON file. I guess let's be like this. Okay. So right now, if I go to the sandbox, I'm gonna have 5 different directories with the configurations of them. You, for example, can open the seed node configuration file, and you're gonna have the nodes with different ports, and each port has correspondence to a different node in your JSON file. Okay, so the next thing to do is to actually start the sandbox. For that, you're just simply going to use the command start, and it will start all the nodes in the network. It will initialize them, and they will be running. One thing to mention is when you just simply write start, it will start all nodes, but you can also give it a name, for example, start miner, and we only start miner, or you can give it a list start miner and seed, for example. Right now, I'm just going to start all of them. So you can see there are 5 nodes head start. And if I'm going to run a column like this one, you're going to see process IDs of them. So actually 5 actual full nodes right now are running. There is also one command that is called CMD that lets you redirect any API call to any node in your network. So basically you can run CMD miner get info. So the node is being configured, the wallet is loading. So as soon as the wallet is loaded, okay. Someone's there. Okay, now you can see there are 18 blocks generated in the newly created local testnet environment. And as you can see, there are 66 already. It means that blocks are generated very, very quickly. So the next thing you need to do is to run a simulation command until 500 blocks are generated in the network, because the first 500 blocks will be generated using the proof of work consensus mechanism, and after that your network has to switch to the proof of stake mechanism. It has already generated half of them. So I'm just going to run sim, which is a simulation command. And while it's working, I'm going to explain to you what the simulation does. So simulation has 2 main purposes right now. It sends coins from the miner to a wallet that you choose, and it also sets up masternodes automatically. That's what's happening right now. It's set up a first node, but it's sometimes it's glitchy and it doesn't always actually set up all nodes right away, so you can rerun it. So in order to send actual coins from the miner to a wallet, you're gonna have to provide a send to property here. So you probably ask yourself what it means. So this is for purposes of the simulation. And it sends every 1,000 coins generated. So as soon as the miner generated 1,000 coins, it will send it to the node that you are pointing here. Okay. So basically when the simulation runs, it checks the send to and the masternode's properties, and it sets up masternodes and sends coins to the wallet. But since the miner generates 1 million coins on startup, it pre-mines them, so you don't have to wait for it to generate coins. As soon as you send 1 million coins to your wallet, should be enough for you to do anything you want, setting up masternodes, do some testing, etc. Okay, so let me check. Okay, so right now we can see there are 510, which means we already are generating proof of stake blocks, right? At this point, you don't need a miner anymore, so you can simply stop it. And if you're gonna see how many crown nodes you have, right now I'm gonna have just 4 of them, okay? So you can basically keep testing, do whatever you want. All right, now I want to check how many mass nodes I have because I'm not sure the second mass node was actually set up. So I'm gonna call seed node, for example. It doesn't matter. I only have one node. Okay, so that's some bug in the mass node creation process, but you can always recreate it with the two mass nodes. Right now I'm gonna stop all the nodes and recreate the network. If you're gonna just run the stop command, it will not stop all of them if at least one of them is already stopped. For example, if I'm gonna stop like this, it will try to stop the miner node, but it has already stopped and it will not keep going. So I recommend you just to, if you don't stop all of them, explicitly specify names of the nodes you want to stop. Well, you can actually kill it. Doesn't really matter at this point. Okay, so if I go to here, you're gonna see the actual blockchains. Oops. Okay. So I'm gonna recreate the network. This bug with the mass node doesn't have enough confirmation appears from time to time. I didn't have time to take a look at that. It's probably gonna reproduce once in 6-7 testnet creations. As you saw right now, it was reproduced in one master node and wasn't reproduced on the other one. As soon as we have enough resources, I think we'll fix it. But for testing purposes, it should be enough. Okay, so the nodes are generating. Let's wait a little bit before we run simulation. So I'm gonna mention that again, that the simulation will start sending the minted coins from the miner, the proof of work miner, to the wallet and set up the mass nodes in the network. So it sent 1 million to wallet. It set up the first mass node, and I hope it will set up the second one this time. Yeah. It has a collateral transaction, 3 confirmations. Okay. So as soon as you have the next mass node is none, means that all the mass nodes that are in your JSON structure are generated. So you can press Ctrl C, start in the simulation. You can check which block your network is right now. So as soon as it reaches 500, you can stop the miner and keep it running using the proof of stake. I'm gonna check for stake pointers in our mass nodes. Get stake pointers, I guess. No. Typo. Yeah, it has plenty of them because there are just 2 master nodes here. And for the DevNet, I set up the validity of stake pointers for 7 days. Usually in the mainnet, it has 2 days, as far as I remember. This is done in case you will need to turn down your network and rerun it in a couple of days. If you're going to rerun it after a week, you're going to have to set it up again. But as soon as you have your environment ready, it just takes like 5-10 minutes to do that, or less. Okay, so now we have more than 500 nodes. And if I'm gonna ask how many master nodes we have, oops. Yeah, something like this. You can ask any node about this. Okay, so right now I want to see a wallet. So what I'm going to do, I'm just going to stop it. And I need to go here and run the actual Crown Qt wallet, but I need to set up 2 parameters. The first parameter is the devnet I want to use, so the binary knows to which network to connect. And the second is the actual directory to the wallet. So there are 2 params. And for this purpose, I have another template script, sbwallet.sh, where you basically simply put your path to the Crown Qt, your devnet name, and the wallet. So basically, if you do it a lot of times, pretty often, it's useful just to have one script without any parameters. You just simply type it and it runs what you need. So in our case, just gonna do like this, binary, right? Yeah, binary folder. The devnet name is sandbox testnet. And the data dir is sandbox wallet. It can be any path. It can reside anywhere. I just create it for simplicity. As soon as you set up all the scripts, you simply run sb.sh or sbwallet.sh and it will start what you need. Okay, so we go back to the terminal. Right now, we just gonna have to, I'm just gonna check how many running nodes I have. There must be 3, so I have to stop the actual wallet. Sorry. It's not running. I need to stop the miner. I didn't stop the miner because we don't need it anymore. Okay. So we have right now 2 master nodes and a seed node running. And if I'm gonna type sbwallet, you can see it's running a devnet sandbox test. Okay. It has the balance, more than 1 million crown that were received from the miner first and received by the masternode payments, and right now minting payments and masternode payments. So from this point, you can do any tests you want. You can run commands here. You can do the wallet testings. You can see 2 master nodes enabled for this wallet. And you can actually start NFT framework testing because that's what I was testing. That was my main purpose of using the sandbox. But but I'm gonna explain the comments for NFT and APIs in another video. Okay, so I'm gonna close it, and I'm gonna stop Seed, Lancelot, and Percival. So we don't have any running nodes anymore. And you can start again. Okay, so it's gonna start again using the same JSON file, the same structure. At this point, actually, you can delete the miner so it doesn't start it all, instead of stopping it after each run. But it depends on duration, for how long you want to keep your local testnet. If you're gonna keep it running for at least a couple of days, it probably makes sense to delete from here. But if you just setting up the testnet and then make some changes in the crown core and set it up again, as I mentioned, setting up the testnet with all these scripts just takes 5-10 minutes. You probably can keep it and stop it whenever you want. Okay, so couldn't stop Lancelot for some reason. Anyway, there are no running nodes anymore. I'm just gonna check it one more time. But I guess it was not maybe initialized. You can always go to the logs and check what's going on here, because they're just normal running nodes on your local machine. So yeah, I guess this is it. You can get a checklist. Yeah, just gonna stop it again. Okay, well, this is it. If you have any questions, you can ask them in Telegram or Discord chat. Yeah, thanks for watching. Bye.